Okay, so we've got fx and 3x defined, and we need to express gx in the form fx plus ln a. The fact that it's got fx plus ln a should hopefully give you a clue here. What we're going to do is focus on ln 5x cubed, and we're going to try and separate this. We know that 5 and x cubed are being multiplied, and laws of indices state that if things are being multiplied, we can separate them to log 5 plus log x cubed. Again, laws of indices mean that this 3 can come in the front, so we've got log 5 plus 3 log x, and it's at this point, hopefully you notice that 3 ln x is the same as what we've got up here, and so we simply say that this is log 5 plus fx, and we've written it in this format here. B. The graph of G is a transformation of f. Give a full geometric description of this. Well, if we've rewritten it as fx plus ln 5, then we know that if we have anything added to a function in transformation world, it means it's moved it up or down vertically. So you can use proper geometric, or you should use proper geometric descriptions. So it would be a translation, can't spell translation, of, it hasn't gone across, but it has gone up. And that's one option. You may get away with saying has risen or gone up the y-axis by ln 5. You may get away with it, but to be honest, it's probably worth remembering this mathematical terminology. So it's translation of 0 ln 5. Okay, so we've got the quadratic function here. We know the x-intercepts, and they've asked us to write it in this format. So they've already told us that the value of in front is minus 10. I would suggest in some ways we kind of want to ignore this for now. Let's focus on our x-intercepts. So we know that if we're given our x-intercepts, we should start off by saying that y equals a bracket x minus p x minus q. We know that they're at negative 4 and positive 6, so we would have y equals a x plus 4 x minus 6. We then focus on any information they've given us. So in these questions, they normally tell us the vertex or the y-intercept. So in this case, obviously, they've told us the y-intercept. So at that point, we know the value of x and y. We know that at y-intercept, x is 0, y is 240. So we step 240 and 0 into those two positions. Oops. So we get 240 equals a, this one's negative 24, so a is negative 10. So that's just to confirm our total formula is y equals negative 10 bracket x plus 4 x minus 6. Now, as I said, I went through that whole thing just in case they don't tell you this negative 10, but we've written it in this format. So we now need to find another expression for fx in the form of negative 10 bracket x minus h plus k. So we have a couple of different options here. This is in completed square format. So we could expand it and complete the square. That will probably take a little bit longer. Or we could identify that this value of h and this value of k tells us where the vertex is. Now we know that parabolas are symmetrical. So if we're crossing at negative 4 and positive 6, there's a 10 unit width here. and we know that the vertex would happen halfway between that, so at the value when x is 1. So all we need to do now is find the value of y at that point. We can do that by substituting that value in. So y would equal negative 10 bracket 1 plus 4, 1 minus 6, 5, 1 minus 6. So that would be at positive 250, because 5 times negative 5 is negative 25, times negative 10 gives positive 250. So we know that the vertex is at the coordinate 1, 250, which means in completed square format it would be y equals negative 10 bracket x minus 1 squared plus 250. Show that fx can also be written in that form. So obviously this is just going to involve expanding out one or both of your previous answers from A or B. Neither is more simple than the other. I'll show you both just in case. So if you've got negative 10 x plus 4 x minus 6, let's focus on the brackets first and expand those. So we've got x squared minus 6x plus 4x minus 24. Simplify that. Oh, sorry, minus 2x minus 24. And expand that out to negative 10x squared plus 20x plus 240. Looking at the completed square format, again we have to focus on the brackets first. So we would have negative 10 x squared minus x plus 1. So that's negative 10 x squared minus 2x plus 1. So negative 10x squared plus 20x minus 10 plus 250. Negative 10x squared plus 20x plus 240. Okay, and on to the next part. Particle. So we're talking about velocity, and we're talking about when it's greatest. So hopefully you recognize that things are at their greatest or at their maximum when the derivative of the function is equal to 0. So di, so we are differentiating. So in other words, we're finding v dash. So our power comes in front, so it's negative 20t plus 20. Obviously the other term disappears. At greatest when v dash equals 0. So 0 equals negative 20t plus 20. 20t equals 20t equals 1. So the velocity is greatest when t is 1. And we now have to find the acceleration of the particle when the speed is 0. Remembering our relationship between displacement, velocity and acceleration, we know that acceleration is found by differentiating the velocity expression. So we already know that acceleration is equal to negative 20t plus 20, but we need to establish the acceleration when the velocity is 0 or when the speed is 0. So first of all we need to find that. So we find the speed at 0 by placing 0 in place of the v. So we would have 0. So 0 equals 240 plus 20t minus 10t squared. I would bring this into factorized format, so I'd go back up to the top, recognizing this is the same. So we can go all the way up here and identify that we've got x plus 4 and x minus 6. So we've got t plus 4, t minus 6. So it's at 0 when t is negative 4 or positive 6. Obviously, time cannot be negative, so at 0 when t is 6. So we're going to stick that value of t into the acceleration expression. So acceleration is negative 20 times 6 plus 20. So that 6. So that's negative 120 plus 20. So acceleration is negative 100 meters per second squared.